layout, you can see it. This is a tube, metal tube, and we make a slit here so that you can see it only for demonstration purpose. And normally, when I drop, this is a magnet, you know, these two are magnet, yeah. And when I drop it, it just drop like this normally. What is the rate of dropping? Acceleration is 8? 9.81, very good. 9.81 meters per second square. Now, if I put this in, try to see what happens. Slower. Maybe I put 1. Alright, 3, 2, 1. Why would this happen? They are friction. Seems, yeah, I think this is a legit thinking, but not really about friction. Yeah, something to do with, of course, cutting magnetic field. Some may ask me, hey, just simply because it's magnetic, so like this one, it won't fall down, right? Like if you try to push a body, it will. But if I try to show you, guys, look at this. This is not magnetic at all. This is not magnetic. It will drop, right? It's not magnetic. So how come? How would this slow down? Yeah, so yeah, of course, this magnet will have magnetic field. And what would they do with this stick? Well, the tube actually will cut the field. Then what happened? So how come cutting this tube, this metal tube, cutting the field will slow it down?
Is it like the field will reflect back to it?
Reflects the B field. No, not really. Well, if I use a paper, try to make paper make this. If I drop it, will it slow down?
Maybe.
No. Can you help me to hold at the bottom? Oh, sorry. It won't.
Nice catch.
It won't.
Nice catch.
It won't, right? I mean, this very common. Like if you ever try before, it would not. It would not, right? So how come the metal tube will make a difference? It's metal, right? It's conductive. So what? So what? Right? Actually, you got the idea. This will cut the B field. And according to what you learn, when you cut the B field, what will you have? No what?
There will be a voltage.
There will be a voltage. That's a good point.
I will be connected to the.
No.
Very good. You induce voltage. And if that can make a complete circuit, you can also induce.
The air. Friction.
You induce EMF. You induce voltage first. And if you could have the complete circuit, you will also induce the currents as well, right? You induce the currents as well. So how come? Well, of course, I will not get electric shock here because it's so small. But how come inducing current within this tube will make it go slower?
Is there
Yeah, kind of.
So both of them has a so they will two materials will cut each other.
Okay, very close idea. Very close idea. You can imagine that according to Land's law, are you ready? Land's law, when this B field, this magnet B field go along with it, this will cut the B field, right? And this will induce a current with a direction that is opposed the B field. Just like we had the coil before, and then if we draw the magnet onto it. We said this is North Pole, and this would also try to act like a North Pole as well. And actually in this case, it should also slow down. But just it wasn't that easy to notice. If last time I dropped like with the coil over there. This one, more obvious because you can see it can conduct much more within itself. So in terms of energy, you can also understand as well. What is the energy when you have the current? What do you call that energy? For currents. In year 9, you heard about it. Electrical energy, right? Electrical. So where does this energy come from? In this case, it's in the tube, but in the first place, where does it come from? Gravitational potential, maybe? What else other than that? Kinetic, very good. So again, if I drop the magnet, it drops very quickly. And that's just GPE turning into KE. But now if I put it inside, GPE doesn't only change to KE, but it also changes to the electrical energy as well at the same time.
So therefore there is less KE.
Yeah, exactly. You can't fully convert into KE. So part of it, but still some of them turn to KE because it's wool still, right? But it can't turn into fully KE. Some go into electrical.
Then if you have a very long tube, make it stop.
Not really, because the force is still not as strong as the weight. It will slow down only. Yeah. So the current within the tube, we have a name for it. We call it eddy current. Can you write down? This is actually not written in your notes. But find a space and write it down. This is pretty good, pretty interesting. And there are some applications of using this as well. And I want you to think about it. But before that, let me show you a video.